Okay, so first thing here with 4.1, welcome back to Unit 4, or welcome to Unit 4, I should say. First thing we're going to review is slope. Now, you've talked about this before, so it will be review. Slope we refer to, or we say, is the rise over the run. The rise meaning up and down, right? The change in the y coordinates, right? Here's the y-axis. Over the run, the side to side, left to right, the change in x. Okay, here's the x-axis, side to side. So we've got the run here, from this spot to this spot, and we've got the rise here, the y difference. We often write that as delta, which means change in y, divided by the change in x. Or another way we can write that, if I can fit this on here, is the change in y's. So the second y coordinate, subtract the first to find the change, and the change in x's, the second x coordinate, subtract the first x coordinate. So for example, let's look below here. We're seeing 2 points on a line, and if I would draw a quick sketch of it, it would look like this, right? 5, 3. Hopefully remember how to plot that. It would be x, y. So 5 on the x, down 3 on the y would be that first point. The second point, -1, -9 would be there. And if I would join those two lines up, you can see the slope there of the orange line. Okay, so put arrows on there. So to find the slope here, we use the change in the y's, so change in the rise divided by the change in the run. Oops, sorry, a 1. And we plug those numbers in. Now we can see here that this line is going up, right? This slope should be positive. If we don't get a positive for our answer, there's a problem somewhere. So you can, even without sketching this, you could imagine where these 2 points are. You can imagine a line going through them. You would know it would be pointing up. Should be positive. Okay, so we've got our first point. Let's call that point number 1, point number 2. Okay, second y is -9. Subtract the first y, -3, divided by the second x is -1, subtract the first x. And our answer will be -9 plus 3, -1, subtract 5. Our slope is 1. For every y that it goes up, it goes over 1x. +1 slope, correct. Okay, looking down then, the next page, we're looking at slope as a rate of change. So we can look at this graph here. We know that the slope of this graph is going to be the change in y, but in this case, y is the dollars, money. So we're talking about a change in the money as it relates to the change in the x's, and in this case it's hours. So you know, common sense says your change in your weekly earnings depends on the change of your hours. Obviously, if you're working more hours, your earnings changes. So in this case, we have our slope would be here's this point and here's this point. So we're finding 2 points on the line that are right on the grid. So this would be 40 hours yields $500. Here, 10 hours yields $100. What's the slope here, or what is the rate of change? Okay, well, the change in the money, 500 subtract 100. The change in the hours, 40 subtract 10. We've got 400 over 30, which if you find the decimal, then you can do the division and you'll get a rate of change that represents this graph. Okay, pause it and turn to page 153. Let's do the your turn together. Good. Randall was traveling along a level highway at a speed of 100 kilometers an hour when she took her foot off the accelerator. After coasting for 500 meters, she noticed that her speed was now 25 kilometers an hour. She's slowing down, right? We're going to find the slope of her descent, or the change, or the rate of change is going to be negative. She's going from a fast to a slow. So it says find the slope of the line segment connecting these 2 points. That's represented by the paragraph. The slope, or the 2 points, are 0, 100, and the second point 500, 25. We know the rate of change, or the slope, is represented by the change in y's, the rise, over the change in the runs. So the change in y values would be 25 subtract 100, divided by the change in the x values, 500 subtract 0. Okay, we're going to get then negative 75 over 500, which yields, if we were to reduce it then here. So if you look at the graph in part B, you're asked to then interpret this answer. What does this rate of change mean? So if you look at it, for every 20 meters, this is the change in the x's, this was the meters, for every 20 meters, she slows down, or there's 3 kilometers per hour less. She slows down 3 kilometers an hour. You can see that's in the graph in part B as well. Let's look at number 3 and review some equations that we need to know when we're talking about lines. The slope-intercept form is an equation that you memorized, and just a few things about it. We know that m, as we've talked about just now, represents the slope, right? The rise over the run, or the tiltedness of the line. And if the line is going up, it has a positive slope. And we know if the line is pointing downward, left to right, it has a negative slope. Negative. The B represents the y-intercept, the place where this line crosses the y-axis. Okay, another equation that we often use is this one. Now this comes directly, if you turn 2 pages back, comes directly from here. Okay, it's the same slope formula. We've just manipulated it a little bit by cross multiplying. And so if you have 2 points, you can use this point slope formula to determine any of the missing variables. Another equation to remember is that if we have a horizontal line, we're going to have an equation with a y in it. So for example, if I have an equation y equals 3, and I would draw a little graph of y equals 3, there's the plane, and y equals 3 would be this horizontal line, right? Okay, same if I have an equation of a line that says x equals a certain number. Now, these are cute little graphs, but here's my coordinate plane. And let's say I had x equals, I don't know, 10. If I would draw x equals 10, it would be a vertical line, everywhere where x equals 10, and of course y is 0. It's not written in the equation. Another equation we need to remember is the general form. It's written like this. So if you're asked for the general form, you would move all the terms to one side so that the equation equals 0. And a, b, and c are not decimals or fractions. F tells us, or reminds us, that parallel lines have equal slopes, which makes sense if you consider 2 lines, this line here with that positive slope, and this line here. Obviously they're the same tiltedness, they would have equal slopes, same slope. M is the same for those lines. Perpendicular lines, on the other hand, We know that perpendicular means they're at 90 degrees to each other. So you look over here on the right, if I have a line like something like this, that would have a negative slope, right? It's going down. If I have a line that is perpendicular to that, so they form a 90-degree angle, let's say this slope is, I don't know, negative 7/8. The perpendicular slope have a negative reciprocal. So if that slope is negative 7/8, the slope here would be opposite sign. That's where the word negative. So it would be a positive and reciprocal. 8/7 would be the slope. Okay, so parallel lines and perpendicular lines, you can tell their slopes by looking at each other's slopes. Okay, a few examples here. Let's turn to page 154, your turn, number 3. Try to read them through those questions, and here are the answers when you're done. Okay, let's do one or two of these examples together, and then I'll let you do your work. So find the equation of each describes, writing your answer in general form. Okay, so we need to start in slope-intercept form. That's this. The variables we need, I usually list them here. The information we're given, we know m. We know an x, that's 5. A y is -9. So we have to find b here in order to write the equation. So let's stick the information in that we know and solve for b. So once you've solved that, then we know that b is -17/3. So once we know 17/3, -17/3, we can plug that into our equation. So we know that y equals m x plus b. And now we need it in general form. We know that general form is ax plus by plus c equals 0. So we bring everything to one side, and we'll have positive 2/3x plus 1y plus 17/3 equals 0. Then we multiply everything by 3 because we're not supposed to have fractions. So if we multiply everything by 3, there's our answer in general form. Okay, B is the next difficulty level because it doesn't tell you the m. It gives you 2 points. You need to use the equation to find m. So we do the here, let's make this 0.2, this 0.1. The y of 0.2, subtract the y of 0.1 over the x of 0.2, subtract the x of 0.1. Okay, and so then your m is, once you reduce it, -3/2. You pick x and y. Either of the points will work. Let's pick the first point. X is -4, y is 8. You need to find b. Now, it's the exact same steps as above. We find b, and we stick them in, and we put them in general form. I will leave you to pause it and do that work. After the work, you find that b is 2. You plug that all in and put it in general form, and there is your final answer. When we look at C, it's given us 1 point, so right away we know the x and we know a y. We don't know the slope or the b. It does tell us that this line that we're trying to find the equation of is parallel to this equation. So we need to find the slope here in order to know the slope of our line. Okay, this is in general form. Let's move this and put this into slope-intercept form so we know the slope. Okay, we want the y to be alone on one side. So the first step would be to subtract the x's. Subtract the x's from both sides. -2. Oh, and let's move this 8 over while we're at it. Is equal to -7x plus 8. And then we want the y alone. We divide by 2 everywhere. And y, for this line over here, is 7/2, that's the m, minus 4, that's the b. But it's this we're concerned about. The line we're looking for is parallel to this one, so they have the same slopes. So now we know that. And now you can go through the exact same steps from the previous questions. The final answer I will write down for you. Example D tells us the line we're looking for is perpendicular to this one. So we find this one's slope, and then we take a negative reciprocal. Then it's the same steps as the previous examples. Question E is exactly like question B. Go ahead on your own and do it. Good luck.